In today's class, we are going to see exercise 1.6, which is of multiple choice questions. Let us begin. So the first question is, if n of a cross b equals to 6, then we are given with a value as 1, 3 and we have to find n of b. We are given with 4 options to find n of b. Okay, let us do it. So we are going to use the point n of a equals to p, n of b equals to q, then number of elements of a cross b which is equals to pq. We know this point already. To solve this problem, we are going to get the help of this point, that is, we are given with n of a cross b. n of a cross b is 6, and also what we are given with is number of elements in A. We can find it with the set A, that is, number of elements in A is 2. So in order to get 6, which number should be multiplied with the 2? That will be the value of n of b. In order to get 6, we have to multiply 3 with 2. Therefore 3 2s are 6. The value of n of b is 3, which is option C. So the next problem is, A is given as ABP and B set is given as 2, 3. C set is given as PQRS, and we have to find number of elements of A union C, cross product it with B. We have to find the value of this from these 4 options. Let us do it. We have to find number of elements of A union C cross B. First we have to find A union C. A union C is, A value is A, B, P, union C set is P, Q, R, S. If it is union, we have to write all the elements from both the sets. So let us write it in an order. It will become A, B, P, Q, R, S. Now what we have to do is A union C, cross product it with B. A union C is A, B, P, Q, R, S. Cross product it with B set is 2, 3. We know to write the cross product, taking the first element, pairing with both the elements in the next set, that is A, 2, A, 3. Next B, 2, B, 3. Next P, 2, P, 3. Next Q, 2, Q, 3. Next is R, 2, R, 3. S, 2, S, 3. Now we have to find number of elements of A union C cross B. Let us do it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, it is option C is the right answer. Next question is, 4 set of values A, B, C, D is given and we need to check which of the following statements are true. For that we have to do it one by one. First subdivision, what we are going to do is, we have to cross product A with C. We have to check whether A cross C is a subset of B cross D. Let us do it. First we have to find A cross C. A cross C is A set cross C set. A cross C can be written as 1, 5, 1, 6, 2, 5, 2, 6. Next we have to find B cross D. B set is 1, 2, 3, 4. Cross D set is 5, 6, 7, 8. B cross D can be written as 1, 5, 1, 6, 1, 7, 1, 8. Next is 2, 5, 2, 6, 2, 7, 2, 8. Next is 3, 5, 3, 6, 3, 7, 3, 8. Next is 4, 4, 5, 4, 6, 4, 7, 4, 8. Now what we have to check is whether A cross C is a subset of B cross D. Let us do that. If I take 1, 5 in A cross C, it is present in B cross D. Next, if I take 1, 6, it is present in B cross D. 2, 5 is also there in B cross D. 2, 6 which is also there in B cross D. So, all the elements in A cross C must be present in B cross D. Yes, it is. Luckily, for the first option itself, we got the answer. For the third problem, option A is the right one. We need not check other three because for the first option itself, we got the answer. Okay, the next question is, if there are 1024 relations from a set A to set B. Set A is given with 5 elements, whereas set B is not given. We have to find the number of elements in set B and we are given with 4 options. For this, we are going to take the definition of a relation, that is, if n of A equals to P and n of B equals to Q, then the relations exist from A to B is 2 power PQ. Now what we are given with is number of relations, that is the total relation is given 1024, which is equals to, we have to use the point 2 power PQ. Okay, and one more point we are given with this, we are given with the number of elements in set A, which is 1, 2, 3, 4, 5. There are 5 elements. Therefore, 1024 which is equals to 2 power 5 into, we need to find the value of Q. This is very easy to find because for which power of 2 we will get the value 1024. So, if I multiply 5 2s are 10, 2 power 10 value will be 1024. Therefore, the number of elements in B is 2. B is the right option. Next question is, the range of the relation R is equals to, R is represented as x, x square, wherein this x is a prime number less than 13. We need to find the range of the relation for this x value. In this, we have to consider x value as a set of prime numbers which is less than 13. So, x should be considered as 2, 3, 5, 7, 11. These are all the numbers, prime numbers which is less than 13. Now, we have to find the range which is equals to x, x square. First, x value is 2. If it is x square is 2 square is 4. Next, x value is 3. 3 square is 9. Next, x value is 5. 5 square is 25. Next, x value is 7. 7 square is 49. Next, x value is 11. 11 square is 121. This represents the range 4, 9, 25, 49, 121. So, which is the right option for this problem? In the next problem, ordered pairs a plus 2, 4 and 5, 2a plus b are equal. If these two ordered pairs are equal, we need to find the value of a and b. Let us do it so. So, these two are equal, that is a plus 2, 4 which is equals to 5, 2a plus b. We have to compare the first element with the first element, second element with the second element. So, a plus 2 equals to 5, a equals to 5 minus 2, a equals to 3. Now, we have to consider second portion and we will find the value of b. 4 equals to 2a plus b. 4 equals to, we already found the value of a which is 3. 2 into 3 plus b. 4 equals to 6 plus b. Taking 6 to the other side, 4 minus 6 which is equals to b. Therefore, b equals to minus 2. So, a value is 3, b value is minus 2. Option D is the right answer. Next problem is, n of a equals to m, n of b equals to n, then the total number of non-empty relations that can be defined from a to b is we have to find. That is, we are given with n of a and n of b elements. We have to find the relations from a to b. We have to take only non-empty relations from a to b. We already saw in the fourth problem itself that if n of a equals to p, n of b equals to q, then the relations exist from a to b is 2 power pq. See, in this problem instead of p and q we have m and n. So it can be written as 2 power mn. Next, we are asked only to find the non-empty relations. If it is non-empty relations, which will be 2 power mn minus 1. Why am I saying minus 1 is, whereas in relations we will find only by writing, that is in a relation is a subset of a cross b. Whereas while writing the subset, we will get one empty set. So that empty set should be eliminated from this value. That is why from 2 power mn we have eliminated that empty set, which will give us 2 power mn minus 1. So option C is the right answer. In 8th problem, the ordered pairs a, h and 6, b represents an identity function. We have to find the value of a and b. It is so easy to do. We know that what is an identity function is. What is an identity function? If the image and the pre-image are the same. That is x, x is an identity function. 1, 1 is an identity function. 2, 2 is an identity function. Whereas image and the pre-image are the same. We have here, it is 8. So the a value will also be 8 if it is an identity function. Similarly, we have 6 as in x position. The value of y also must be 6. So which is 8, 6. 8th option is 8, 6. Therefore, this is the right option. So next question is, a is given as 1, 2, 3, 4. B is given as 4, 8, 9, 10. A function f is a mapping from a to b, which is given by the function, and we have to find out using this function which type of a function this relation gives us. So let us do it. So a set is given as 1, 2, 3, 4 and the b set is given as 4, 8, 9, 10. F is a mapping from a to b and the relation is given as 1 is mapped to 4, 2 is mapped to 8, 3 is mapped to 9 and 4 is mapped to 10. What is this function is? This is a one-to-one function because every different elements in A have different images in B. Therefore, option C is the right answer. Next problem is f of x is 2x square, g of x is 1 by 3x. Then we need to find f composite g. This is so simple. We saw what is f composite g in the previous class itself. Let us do f composite g of a function f can be written as f of g of x. What we have to do first? We have to substitute the value of g of x. What is the value of g of x given in this? 1 by 3x. Now we have to use the function f, which is 2x square. In place of x we have to substitute 1 by 3x. So 2 into 1 by 3x whole square. 2 by 3, 1 square is 1, 3 square is 9, x square. So option C is the right answer. Next question is, if f is a mapping from a to b is a bijective function. What is a bijective function? 1 to 1 and on to. And if n of b, that is number of elements in b is 7, we need to find the number of elements in a. This is very easy. Why am I saying it is easy is, bijective function, as I told you, it is 1 to 1 and on to. According to the 1 to 1 function, every elements in the set A must have distinct images. If the number of elements in set B is 7, then what will be the number of elements in set A? This will also be 7. Let f and g be two functions given by f is given as a function in such a way and g in such a way. Now we have to find the range of f of g among these. Let us do it. F of g is represented as f of g of x, and we know by the composition of functions definition, f is a mapping from a to b and g is a mapping from b to c. Okay, so first let us do that. A value is, that is all the first elements in a set of ordered pairs represented as A, all the second elements is represented as B. So 0, 2, 3, 4, 5. Second set is 1, 0, minus 4, 2, 7. Similarly, we will do it for G, B to C, 0, 1, 2, minus 4, 7. Next is 2, 0, 4. For the F, it is 0 is mapped to 1, 2 is mapped to 0, 3 is mapped to minus 4, 4 is mapped to 2, 5 is mapped to 7. In F function. In G function, 0 is mapped to 2, 1 is mapped to 0, 2 is mapped to 4, minus 4 is mapped to 2, 7 is mapped to 0. Now what we have to find is, we have to find f of g of x. So first thing is f of g of 0. Why I am writing g of 0 is this value, f of g of 0. G of 0 means the mapping 0 as is 2. So f of 2, because g of 0 is 2. So instead of g of 0, I have replaced it as 2. Now we have to look at the function f of 2. F of 2 means f2 is mapped to 0. We got the one range value. Next is f of g of 1. That is f of g of 1 is mapped to 0. Now we have to look at the f function. F of 0 is mapped to 1. Next, f of g of 2, whereas g of 2 is mapped to 4. Now we have to look at the function f. F of 4 is 2. Next is f of g of minus 4. Minus 4 is mapped to 2. F of 2, whereas f of 2 is mapped to 0. Next, f of g of 7. Therefore, f of 7 is mapped to 0. F of 0 is mapped to 1. So, 0, 1, 2 is the range value for f composite G. So, option D is the right answer. So, in the next problem, f of x value is given as root of 1 plus x square, and we have to find which of these relation is satisfied when f of x is equals to 1 plus x square. So, what will we do is, f of x is given as square root of 1 plus x square. We need the value of f of y, because in all the relations we have f of y, and also we need the value of f of xy, because in all the relations we have f of xy. So if it is f of y, what it will be? Same, square root of 1 plus y square. If it is f of xy, then it will be square root of 1 plus xy squared, which can be written as 1 plus x squared y squared. Now what will we do is, we will take the x value and y value, we will assume one value, and we will find which of the relations is satisfies. Okay, so first I will take x value, let us assume. We will assume x equals to 1 and y equals to 1. If x is equals to 1, let us substitute in this. F of 1 will become 1 plus 1 square is 1, so root 2. Next, if I assume y value was also 1, it will become again 1 plus 1 root 2. F of xy, it will also 1 plus, both x and y are 1, 1 plus 1 square root of 2. Now, what will we do is, among these three relation which satisfies this value, let us check and we will mark the value. So, first if I take f of xy, which is equals to f of x into f of y. So, we got the value of f of xy as root 2. F of x is root 2, f of y is root 2. this root 2 will remain same. Root 2 into root 2 will become 2. So this condition is not the right condition. We will go for the second one. Second one is B option is f of xy, which is greater than or equal to f of x, f of y. F of xy we got as root 2, greater than or equal to root 2 into root 2, which is greater than or equal to root 2 into root 2, again will become 2. Whether root 2 is greater than or equal to 2? No, it is not. So the second option is also not satisfied. Let us check for the third option, f of xy, which is less than or equal to f of x into f of y. F of xy is root 2, f of x is root 2, f of y is root 2. Root 2 which is less than or equal to 2. Yes, this condition is satisfied. Therefore, third option is the right answer. Next problem is G relation is given as such. Is a function given by g of x is equals to alpha x plus beta. We need to find the values of alpha and beta using this relation. So g of x is given as alpha x plus beta. Considering this as a first equation, we will take the first pair 1 comma 1. This is the value of x and this is the value of y. This g of x is nothing but y. So y value is 1, which is equals to alpha into x value is also 1 plus beta. This we will consider it as second equation. Next we will take the pair 2 comma 3. This is x, this is y. Instead of y we have to substitute 3, which is equals to alpha into x value is 2. So 2 alpha plus beta. This we will consider it as equation 3. Now we will solve equation 2 and 3. Therefore we will get the values of alpha and beta. Alpha plus beta equals to 1, that is second equation. 2 alpha plus beta equals to 3, third equation. So solving this using linear equations, we will change the signs. Plus beta minus beta will get cancelled. Minus 2 alpha plus alpha will become minus alpha, which is equals to minus 2. So alpha is equals to 2. Next, substitute the value of alpha as 2 in any one of the equations. We will do it substitute in the second equation, that is alpha plus beta equals to 1. Value of alpha is 2 plus beta equals to 1. Beta equals to 1 minus 2. Beta equals to minus 1. So alpha value is 2 and beta value is minus 1. So option B is the right answer. So now we are given with f of x is equals to x plus 1 whole cube minus x minus 1 whole cube, which represents which type of equation it is, we have to write. So for that we will consider f of x is equals to x plus 1 whole cube minus x minus 1 whole cube. This we will expand using a plus b whole cube formula, and this we will expand using a minus b whole cube formula. A plus b whole cube is a cube plus 3a squared b plus 3ab squared plus b cube. Similarly, a minus b whole cube is a cube minus 3a squared b plus 3a b squared minus b cube. For the first one, a plus b whole cube, it is a value is x and b value is 1. Let us directly substitute. So f of x is rewritten, can be rewritten as a cube. Therefore, x cube plus 3 into a square is x square into 1. So 3x square plus 3ab square. 3 into x into 1 square is 1. So 3x plus b cube is 1 cube is 1. So this is the expansion of x plus 1 whole cube minus, we will expand x minus 1 whole cube. Now also the value of a is x and the value of b is 1. We will expand. So first if it is a cube, x cube minus 3a squared b, which will get it as 3x squared plus 3a b squared, that is 3x minus 1 cube is 1. We will simplify by removing the brackets. X cube plus 3x squared plus 3x plus 1 minus x cube plus 3x squared minus 3x plus 1. So minus x cube plus x cube will get cancelled. plus 3x minus 3x will get cancelled. The remaining what will we get is 3x square plus 3x square is 6x square. 1 plus 1 is 2. So it starts with the power of x as 2. It is a quadratic equation. Option D is the right answer.